Hi, uh, hello, hi, Professor. Today I'll be doing a classification problem on the Spaceship Titanic Kaggle competition. So our target variable here is transported. So what we have to do is whether to see the passenger has been transported to an alternate dimension or not. The training data has 8700 records, the testing data has 4300 records. So these are the variables that help us predict whether the passenger was transported or not. Passenger ID has a group number, a group to which a passenger belongs, and the patient number, the number of the patient, the home planet, the planet from where the passenger took flight from, cryosleep, whether the passenger opted for a cryosleep or not, cabin, like which deck number the passenger is at, which number is the passenger at, which side of the deck the passenger is at, destination, the place where the passenger has been transported, will be transported to, age, what's the age of the passenger, VIP, whether the passenger took a VIP service or not. These are the expenditures of the passenger. This is the name of the passenger, and this is the target variable. So this is where we do the scoring, where we get the score when we submit the data, the submission data. So this is the pandas Jupyter notebook that we have used. So first we do is like we take in the training set, take the head of it, then we drop the name because it's not important. The name is not important for the classification. Target feature, we take the target feature, and then we take the like the feature that is not targeted. That is the x variable and the y variable. XSTF is all those columns which help in making the classification. Now we handle all the missing values. For the missing values, we take this. For the for the numerical types. For the non-numerical types, we do this. Then using a simple imputer, we convert all the numerical values into that are missing from replace them with the median, and the categorical values which are missing replace them with the most frequent, that is the mode. Then after covering up all the missing values, we check whether they are still missing, and it shows that none of them are missing. Next we do is we handle categorical data by replacing it with like 1, 0 if it's just binary, or if it's not, we give a rank like 1, 2 or 3, 1, 2, 3, 4, 5. So after cleaning up all the categorical data, we end up with this, and then we do a feature extraction, taking out those data, engineering, taking out those data that are most relevant to it. So passengers belong to a particular group, right? So what we do is we try to extract the group from the passenger ID, and this is what I have done. Uh, Extraction of the group from the passenger ID, and then what we do is we take the cabin. So in the cabin we have this is what is the deck type. This is the deck number, the passenger number, and the side of the deck. So we see that the side is whether it's port or it's a starboard. Again, like you take it out, and this is like then we no longer need the passenger ID because we take out what is relevant, that's a group, and then we remove it. At the same time, the passenger, the number inside the cabin is not that important, so I didn't extract those. I just took the deck and the deck side. That's B and P, F and S, blah blah blah, like that. So then we take out them. These are categorical in nature again. Then we associate them with numbers again, and then we finally have something which just has numbers. Then we take out the expenditure, which is like a combination of all these, so that our features get reduced significantly. And this is like why finally the features which are getting reduced. And then for taking out those features which are having the highest rank, I do feature selection, then select K best features with a sky score, and we see here like this, these four features are the most relevant. The others, the deck has significantly lower score than the age, and that's why these top four features have been taken into account. Then we drop the rest of the features, finally take this, and then we scale the features. Scaling the features is very important so that every feature has an equal contribution towards the classification. Then we do a splitting where we do a 80-20 test train split, and then these are all the models that I have used, a bunch of classification algorithms, and finally I see that after using all these models, the support vector machine classifier has the best prediction results, since the difference between the training set and test set score is really low, and hence I go with a support vector classifier. Again, for the same final test, that is the data that needs to be tested upon with the most accurate model, I kind of do the same steps so that taking out the most relevant features which help in prediction, and then doing all those bunch of steps which are actually a repetition of what is done above in the training data, we come to a final prediction that's been done with the kernel's SVM classifier. And this is the final data that is taken, and it's finally submitted to a submission.svscv. Then here in the spaceship final page, the leaderboard page, I get the 72.597% accuracy and 1603 rank. Um, Thank you, Professor, for giving me time. I really hoped of doing the data set that was earlier. Probably will target for the data set in the summer. Besides that, a lot of modeling was not that great, but a lot of pre-processing was done, which has been taught in the class. So I'm pretty content with what the given situation is. Thank you.